Okay, everyone, let's turn to page 285 of our book. It says, for every 4 adults at the beach one afternoon, there were 3 children. How many children were at the beach if there were 8, 12, 16, or 20 adults at the beach? All right, so let's graph our first one. It says, for every 4 adults, we're going to go to the right 4. There were 3 children, so we're going to go right in between here. Okay, and then the next one, we're basically going to double it. If there was 8 adults, which is right here, we're going to double the amount of children, which is 6. Okay, and then if there's 12 adults, which we tripled, we're going to triple the 3 to make it a 9. All right, so 12 and 9 is right in between here. You can see that we're making a straight line at this point. 16, that means we multiplied 4 by 4. So 16 and 12 will be our next one. And then finally we did this by 5. So 20 and 15 will be our last one. Okay, which is right about here. And we'll do our best to create a line. So for our chart, 4 adults, 3 children. 8 adults, all right, well, we double this, that's 6. 12 adults, that means we tripled it, so that's 9. 20 adults, all right, that would be by 5, so that's 15. And then we could also go with 6. 6 times 4 is 24. 6 times 3 is 18, as we continue on. All right, fill that in for page. All right, everyone, turn over to page 286 to follow along. How can you use tables and graphs to show equivalent ratios? Think about the question during the lesson. Ellen is shopping for supplies at Jake's party store. We'll make a table to show how much Ellen will spend to buy 3, 6, 9, or 12 balloons. Then we'll plot the values in a coordinate graph and use the graph to find the cost of 18 balloons. Okay. The ratio 3 balloons to $2 represents the cost of the balloons. You can make a table of equivalent ratios to find the cost of the other balloons. So X will be our balloons, which is represented by 3. The cost in dollars is 2. All right, then we double this and triple it and then quadruple it. So we can multiply 3 by 4 to get 12. All right, so we multiply 2 by 4 to get 8. Ellen can buy 3 balloons for $2, 6 balloons for $4, 9 balloons for $6, and 12 balloons for $8. All right, take note that the balloons are the X values, the cost is the Y values. Then now as we go to plot this, we go over 3, up 2 for the first one. All right, see how to do that. If there's our ordered pair, 3, 2, 6, 4, 9, 6, and then 12, 8 would be our last one. All right, we'll connect the points. We should draw a dashed line. A dashed line is used instead of a solid line. And what do the arrows indicate? The arrow indicates that it goes on forever. All right. A dashed line is used only because you can only buy whole numbers of balloons in ratios of 3 balloons to $2. The arrow indicates that this goes on infinitely, so we could predict whatever we're going to get for the next ones. Right now, what are the coordinates of the point that represents the number of balloons you can buy for $6? So if we look here, 6 is going to be, this is 2, 4, 6, 8, 10. All right, so 6 is right here. This will be right in between, so it's going to be $9. Or I'm sorry, 9. It'll be 9 balloons. Okay, so we put that in. So we have 9 balloons. How can you graph to find the cost of? All right, so 9 balloons for $6. We're not going to worry about the next part. All right, so our coordinates, right, is 9, 6. All right, so that's our coordinates because we go over 9, up 6. How can you use the graph to find the cost of 15 balloons? We can find 15 on the x-axis and then go straight up until you find the dashed line. Alright, so make sure you have that. Okay, everyone, let's turn to page 287 to follow along with example 2. It says Jack is making juice. He has 25 celery sticks. If Jack uses all 25 celery sticks, how many apples will he need to make the juice? Right, so we can set up a table so we can see that 25 celery sticks, and then if we know that 5 celery sticks will get you 2 things of apple juice, we just keep adding by 5, and we add by 2 for the other one. Alright, so we can see that 25 celery sticks will need 10 apples. Alright, we could also graph this. Alright, there's another way of doing it. Jack needs 10 apples to make the juice. Alright, everyone, let's turn over to page 287 in the book. It says the diameter of different circular objects are given in a ratio table. What do you notice about the graph of the pairs of values given in the ratio table? So we have 22 to 7, 14 to 44, 35 to 110. So it looks as if we're basically doubling, multiplying it by 5 to get the next number, all right? So if we use an ordered pair here, setting it up with 722, 1444, we see that we have a straight line because it's a linear equation. It says, can you draw an object with a diameter of 10 inches and a circumference of 50 inches? All right, so if you look, 10 inches, all right, which means that we would have to multiply the diameter by something to get 10, and it's not going to be the case. We're not going to be able to do that. So our answer would simply be no. The point 1050 is not on the line. So based off of the graph here, it's not going to work. So